Okay guys, we're just going to quickly run through some of the families that are in the periodic table. Remember that families or groups go up and down on the periodic table, so that they're the vertical columns. And you also should have a periodic table so you can kind of see where these groups are. Alright, so the first group we're going to talk about are the alkali metals. That's group 1. So if you're looking on your periodic table, it's this group right here. Alright, these are the most reactive metals. They're going to form ions with a +1 charge. So if you remember, in electron configurations, this group will always end in S1. So it will give up that one electron and then make an ion of a +1 charge. Because it's so easy to take this electron off, they are very, very reactive. You don't really find them in nature by themselves. And they're also very reactive with water. So if I take a chunk of sodium and throw it into water, it'll react very violently. They're also soft. So this is a chunk of sodium right here. I can cut it with a butter knife. Now, hydrogen doesn't really fit these characteristics. It's kind of in its own group. Also, a lot of these elements are used in fireworks. So right here, you see that purple color. That should be from potassium. Alright, so the alkaline earth metals, that's just one column over in group 2. So this is group 2 right here, the alkaline earth metals. They have a lot of the same characteristics, it's just not quite to the extreme. So they're very reactive, but they're not as reactive as the alkali. They'll form ions with a +2 charge. So all of these end in S2 in the electron configuration, so they will lose those 2 electrons to become stable and have a +2 charge. They're soft, but they're harder than the alkali metals, and we will work a lot with things like magnesium. Okay, so as we go over to the D block, all of these are the transition metals. Okay, so the whole D block, those are your transition metals. So those are groups 3 through 12. A lot of the properties will vary. When you think about it, you've got gold in there, you've got silver, you have copper and zinc. So those metals have very different characteristics from each other. They're stable and unreactive for the most part. They're hard metals, and then they will form ions of various charges. And a lot of them will form more than one charge. Because of opening that d orbital up, the electron configurations get a little bit funky in there. So they can form ions of different charges. So copper can form a +1 charge. It can also form a +2 charge. Alright, so the lanthanides are in our F block. So I don't need to pull it up the periodic table. It's right here. That's that first row of the F block. Those are called the rare earth metals. You don't really find them in nature very much. They're intermediate in reactivity between the alkaline earth metals and the transition metals. So some of them are reactive, some of them are not reactive. And you'll find some of these used in light bulbs and TV screens as phosphors. So these elements that we use as phosphors, they give off light or luminescence. So the lanthanides, remember, are the first row of the F block. All right, the actinides are right below the lanthanides. So if you're looking at your periodic table, the actinides are right below it. These are the actinides. Okay, a lot of these are radioactive. So those are going to emit particles. They go through decay very readily, and they're man-made. The reactivity is going to vary, and this is the family that contains things that we use for nuclear power and weapons. We also have elements in there that are used for radiation therapy. So when you go to the hospital, if they're treating for cancer, they can use radiation therapy, and fire alarms, surprisingly enough. All right, so the halogens. The halogens are group 17. It's also group 7A. It depends on what periodic table you're looking at to see how they're numbered. But that's group 7A, so fluorine all the way down. These are highly reactive nonmetals. Okay, so they will react. So of the metals, the alkali metals are the most reactive. The halogens are the most reactive nonmetals. They're highly volatile, which means they're readily form gases. Fluorine and chlorine are usually, they are gases. Bromine is a liquid normally, but it usually is very volatile, which means it would escape as a gas very rapidly. And iodine easily sublimes. So that means that solid iodine will easily sublime into a gas. So it goes straight from a solid to a gas. They are strong oxidizers. Okay? An oxidizer is something that pulls off electrons very easily. Because they want that one electron to complete their configuration, they're going to easily pull the electrons off of things. So everything in this group will end with P5. And you know, to become stable, all they need is one more electron to fill up that P sublevel. So they're strong oxidizers. They will readily pull that electron off of another atom. Most of these are diatomic, which means that they come in pairs. So whenever I find F, it's actually F2. Whenever I find chlorine, it's Cl2. Bromine is Br2. Iodine is I2. So that means if I find it in nature, it's not going to be by itself. It won't ever just be a fluorine atom. It's going to be a molecule with two atoms combined. These atoms will form ions with a -1 charge because remember they're trying to pick up that last electron to fill the p orbital. And some of these were used in water treatment, or they are used in water treatment like chlorine, and chlorine was also used as a weapon in World War I. Okay, so the noble gases. Noble gases are all the way over here, that last column, starting with helium. They're highly unreactive, and we all know that that should be because of their electron configuration. They all end with P6. So they either have a full energy level or full sublevel. So they don't want to add electrons, nor do they want to lose them. Some of these gases, because they're unreactive, are used in situations where they don't want a chemical reaction. So a light bulb, you wouldn't really want a chemical reaction going off in that. So they use some of these noble gases like neon. All right, so hydrogen is the really weird one. So remember that it is actually in group 1, but it's not a metal. It's the only non-metal over on this side. Okay. It has very, very unique properties. It is also diatomic, so remember that means it's going to come in as H2. So you'll never find hydrogen as just H by itself. It's H2. It can either form a +1 or a -1 charge. Because its configuration is this, okay, it can gain an electron, which it will do sometimes, and it can also lose an electron. And it usually does form the +1 charge, though. Hydrogen is relatively unreactive unless you add energy to it. So if you take hydrogen gas and you put a spark to it, it will ignite. And it can form explosive mixtures with oxygen, which is thought to have led to the Hindenburg explosion, which is right here. So if you combine hydrogen gas and oxygen gas, that is an explosive reaction. So when you make water, it releases a lot of energy. All right, there are more groups that we could talk about, like the representative elements, but these are the most important ones, and I just want you to know the main properties of those. All right, I'll see you in class.